Question number 2 is just asking us to predict whether it has a horizontal or oblique asymptote. Because of the green part of step 1, it's important that we do our steps in the right order, because we saw in our last example that you could have predicted an oblique asymptote when in reality a factor canceled out and it just became a straight line. There's no asymptote. So we do have to follow the steps, and in following the steps we're going to see what these graphs look like, because we're going to graph them completely. So first of all, in A, we start by factoring. Does this factor at all? Yes, it does. X plus 7, x minus 1. None of the factors cancel, so when we're going to step 1, our non-permissible value, x can't equal -2, and that is a vertical asymptote at x equals 2. It's not going to be a hole because the factor didn't cancel out. Now step 2, we still got the original equation. Now in step 2, we can decide, is there going to be horizontal asymptote or an oblique asymptote? In this situation, we look for the highest degree. The highest degree is an x squared, a degree of 2. That's in the numerator. What happens when the degree is larger in the numerator? That is the third thing that we noticed this morning, and that would be an oblique asymptote. Wow. There we go. How do we find our oblique asymptote? We find it with synthetic division. So we actually need to divide x squared plus 6x minus 7 by x plus 2. If I was dividing that, x squared plus 6x minus 7, dividing by x plus 2, I'd put a minus 2 out there, bring down the 1, multiply, add, multiply, add. And the answer is x plus 4, remainder of -15. Again, you can ignore that remainder. We now know that our oblique asymptote is at y equals x plus 4. Step 3, we can start graphing our asymptotes. We know that we have a vertical asymptote at x equals 2. We have an oblique asymptote at y equals x plus 4. So how do you graph y equals x plus 4? Well, that has a y-intercept of +4, a slope of 1, so over 1, up 1. Again, take out your red pen, draw a dotted line for y equals x plus 4. Those are our two asymptotes. Step 3, let's find our y-intercept. That one's always the easiest. If you go back to your original equation and plug in 0 for x, can you see that you'll get -7 over 2? Zero comma -7 over 2, or -3.5. That's our 1 point. For your x-intercepts, yes? Was it -2 as a non-permissible value? I might have made that mistake. That's very likely. Yeah, x can't equal -2. Sorry, vertical asymptote will be at -2. I'm sorry. Thank you for noticing that. That means this just moves over 1, 2. Oh my goodness. Yeah, just if you wet your finger, this might work. It's so bad, eh? Here. Okay. See, you're supposed to notice my mistakes earlier, guys. Oh, that's a good eye roll. Anyways, that's right. So if we use the factored form for finding our x-intercept, we have 0 equals, and factored form was x plus 7, x minus 1, over x minus x plus 2. Again, if we want a fraction to equal 0, that only happens when your numerator is equal to 0. So we're going to have one x-intercept at x equals 1. And the other x-intercept when x is equal to -7. We need to have at least 1 point per section, and sections are determined by your vertical asymptotes. Do we have a point to the left of x equals -2? Yes, we do. Do we have points to the right of x equals -2? Yes, we do. We now have enough information to graph this. We cannot have any more x-intercepts, and we have to draw our graphs toward the asymptotes. So in this section here, since I have these 2 points, that's not really pretty, but that's what you got to kind of do. Draw it through those points and towards your asymptotes. Can't add any more x-intercepts, so this is what it would look like. Same thing with this one. I need to go towards this asymptote here and towards that asymptote there. Really not very pretty looking graph from this perspective, but that's what it would look like. So we always, at the end, draw our graphs towards the asymptote. We've got all the x-intercepts we have. We've got at least 1 point per section, and we're done. So the process stays the same even though the graphs look drastically different. Like this graph doesn't look anything like the graph we did before, but the idea is the same. You have points in different sections, and then you draw your graph towards the asymptotes. Now those asymptotes are going to change positions. Your x-intercepts and y-intercepts are going to be in different places, so you could get different situations happening. I mean, the other situation in here, it could have been that your points were in between here and here. Then you would have had like a different looking graph, but you still could do it towards the asymptotes. Okay, is everybody okay if I erase this one so we can do B? We're good? Now B is almost identical as far as the numbers that we have. It's going to factor the same, but now our x plus 7, x minus 1 is in our denominator. So we have new non-permissible values. Our non-permissible values, x can't equal -7 and x can't equal 1. None of those factors cancel out. So we have 2 vertical asymptotes. We have 1 vertical asymptote at -7 and 1 vertical asymptote at 1. Okay? Nothing canceled out, so the green note doesn't come into play. We don't have a simplified equation that we need to graph. We're still graphing the original equation. Step 2. Find out if we have horizontal or oblique asymptotes. In this situation, when we look at the highest degree is a degree of 2 in that x squared, and we have it in the denominator. Whenever our highest degree is in the denominator, this will be something you'll have to study and work on. Our horizontal asymptote is always at y equals 0. So as far as our graph looks to begin with, we have a horizontal asymptote at, a vertical asymptote at x equals -7, and a vertical asymptote at x equals 1, a horizontal asymptote at y equals 0. Step 3, x-intercepts and y-intercepts. Starting with your y-intercept. That's easy. Go back to your original equation and plug in 0 for x. If you plug in 0 for x, you're going to get 2 over -7. So for these points, you're going to just have to estimate as best as possible. -2/7 would be somewhere between 0 and -1. X-intercepts. If you make y equal to 0, again, the only time a fraction can equal 0 is when your numerator is equal to 0. And this can happen at x equals -2. So initially, this should feel somewhat wrong, because you have an x-intercept and you have an asymptote at y equals 0. Your graph is going to go through your asymptote. That might not make you feel very good, but it can happen with horizontal asymptotes. A graph can never go through a vertical asymptote, because a vertical asymptote is talking about a non-permissible value. Horizontal asymptotes are telling you what happens at extremes. They're not really concerned about what happens in the middle. So in this case, sure enough, we have an x-intercept that's on our asymptote, and that's okay. How many sections do we have? 3 sections. Do we have points in each of the sections? No. We need a point in the far left. So I'm going to plug in -8, because that would be 1 to the left of -7. I'm going to go up to my original equation and say if x is equal to -8, maybe I'll use my factored one because it's going to be easier to do the math. On the top, can you see that I would get -6? And on the bottom, I would get -1 multiplied by -9. What does that simplify to? -6 over +9, or -2/3. So I go to my graph, and I say, I now know that I have a point at -8, -2/3. With that point in that section, that's enough information for me to graph that section towards the asymptotes. It can't go through either of those asymptotes because we've already found all the x-intercepts, and our vertical asymptotes are non-permissible values. We have points in our middle section, and I can tell you this part for sure has to go through our y-intercept. It would have to go down towards our asymptote, because if it went up towards the asymptote, we would get another x-intercept. Okay? But here we have an issue. And the issue that we have here is it's possible that it could have bounced off of that and gone down towards the asymptote. It's also possible that it could go up towards the asymptote. If we wanted to find out for sure, another point would help. So we can plug in another value. Let's say we chose -5. So I'm going to go back up to my factored equation, erase the purple work from the last one. And now say, what would happen if I plugged in -5? My numerator would be -3. My denominator, this would be +2, and this would be -6. I get -3 over -12, which simplifies to 1/4. So I now know on my graph that I have the point -5, 1/4, which is positive, meaning this has to go up towards the asymptote, and it didn't bounce off. Have we got all the sections? No. We still need something in the far right-hand section, and so go back to our purple here, erase. Plug in x equals 2. If x is equal to 2, my numerator would be 4. Here I would get 9. Here I would get 1. So I have the point 2,4/9. That's a positive number above those asymptotes. So now I know that my graph looks like this. Again, that graph looks nothing like the two previous graphs that we've had. But the three simple steps stay the same. We draw our asymptotes. We find our x and y intercepts. And then we may have to find more points as needed, depending on how many sections we have and whether or not we have points in those sections. Okay? Once you find your x-intercept, you cannot make more x-intercepts. So that's the only x-intercept there could have been. And once you have a point in a section, your graph goes towards the asymptotes in that section. And there's your final graph. Now, something to be careful. You know, we've been losing E errors all along. I'm going to introduce you to E10. So I did not, just let me check. No, I did not lose an E10 in this graph. Okay? One of the reasons, I'm going to erase that part of the graph to show you an E10. One of the reasons I get you to do asymptotes in red pen is very often when there's an asymptote at y equals 0, because the axis is thicker already, some students don't draw it in. Or they draw it in on pencil, but don't make it go past the line, so you actually can't see it because it's so perfectly on that thick black line. You lose a mark if it's not really obviously there. So using a red pen makes you see it on the asymptote better than a pencil. Because, yeah, they've lost marks if you didn't extend it past, or you labeled it without drawing the dotted line. If you draw your asymptote with a squiggle line instead of a dotted line, E10. And the other E10 error for asymptotes is when you go to draw your graph, and your graph is supposed to approach your asymptotes. That's what an asymptote does. Notice how mine sort of whipped up at the end. I was so excited about finishing the question. This part right here went up. It's now farther away from the asymptote here than it was there. That would be another example of an E10 error. So we have to be really careful all the way through that when we go to graph this, This part was good because it's getting closer and closer. This part can't swoop up, needs to get closer and closer as well. Okay, so let's do some practice now. Even though they're asking you only for a small portion of it, I want you to graph 5, 6, and 7, graph the equations completely.